Hopefully you've taken some time to watch the permutations video before you watch the combinations. So what I want to do is I want to jump into when we would use combinations. So we're still looking at selecting a group of items or group of people or things from a larger set of items, and without repetition though. Once you pick someone, you can't pick the same person. They're already chosen. Can't pick them twice, okay? The only difference here with combinations versus permutations is that order is not going to matter. So I don't care if I pick Bobby first and then pick Trisha second, okay? Or if I pick Trisha first and then Bobby. It won't matter, okay? And we'll talk about when that is, like anytime you have like committee meetings or anything like that, or the one example I like to think of is like a fruit salad. It doesn't matter if I put my strawberries in first, then my blueberries, then my pineapple. It doesn't matter which one I'm putting in first, right? Because they're getting mixed all around. Doesn't matter. So that's combinations. Doesn't matter the order. So you're just picking a group of items from a larger group of items, and you can see here the formula. Again, it is intimidating, but I want to show you a shortcut way to use this formula so it's less intimidating. We're going to use that shortcut we used in the permutations video. That's why it's very important to watch that first, to use here. Notice this time instead of a P, you have a C for combinations. You guessed it. Okay. And then N again is going to be the size of your group you're choosing from. And then R is going to be the size of the group you have to choose. Okay. So here are some examples. I always like to do committee work because it doesn't matter. There's no difference between the people, right? Everybody's on the same page there. So we're choosing 2 people from a group of size 14. First number is always the size of the group you have to choose from, and you want to pick 2 people to be in that group. How do we do that? Okay, well, let's start off the same way we did with permutations. How many spots do we have here to fill? We have 2 spots. So how many options do we have for the first spot? We have 14. How many options for the second spot? 13. Go ahead and multiply. So it's just starting off like permutations, same thing. Nothing different here. 182. Now the difference with combinations is we need to divide out any repeats, because remember, order doesn't matter. So if I flip 2 or if I flip 3, it doesn't matter. It'll be the same group for combinations. So what we need to do is divide by the size of the group factorial. So make sure you've watched that video on factorials as well, but just as a reminder, factorials are that count down. So 2 factorial, what you are is you're just counting down to 1. So 2 times 1 would be 2 factorial, which is not very exciting because it's just 2. Okay, don't worry, we'll have a more exciting factorial in the next one. So go ahead and just figure out your factorial first. So 2 factorial was 2, replace it on the bottom. Then go ahead and divide it. So 182 divided by 2 is 91. So here, when you have 14 choices and you only need to pick 2, you have 91 different ways you can do that. Crazy. Okay. Let's look at when we have 9 things to choose from. Actually, a better option would be like your lunch. So you have 9 different food items you can choose from, and you have to choose 4 for your lunch bag to take to work. Okay? Order doesn't matter, right? Doesn't matter what order you pick them in. They're all going to get eaten. So we have 4 items that we need to pick. 1, 2, 3, 4. How many options do we have for the first one? We have 9. And then again, you can't pick the same item, right? So 8, 7, 6. Again, you just multiply them. 3,024. But since, again, order doesn't matter because we're talking about combinations, we need to divide. Again, we need to divide by the size of the group you're picking, which would be 4 factorial. That factorial is going to be important because 4 factorial is that countdown, starting at 4, count it down until 1, and multiply your result. So 4 times 3 is 12, times 2 is 24. Okay, so 24 is actually the number we're going to place on the bottom. So we're going to divide that by 24. What does that give us? 3,024 divided by 24 is 126 different possible ways to pick 4 items. That's it. Okay. You switch out that pizza for like a turkey sandwich, right? That's a new combination of 4 items, even if the other 3 are the same. So that's the number of ways to do a combination. Let's practice though with some word problems. Yay, word problems! I know, it's your favorite. So in a class of 18, your teacher decides to pick a group of 3 students to present a topic. How many different ways can the teacher pick the group? So you're picking a group of items, group of people here, and you need to ask yourself, does order matter? Are we giving them different positions in that group? No, they're just presenting on a topic. So order doesn't matter. That group of 3 is the same no matter if I switch around which order I pick them in. So we need to use combinations. Order doesn't matter. So let's start with our combination C. Boom. Number on the left is the size of the group you're picking from. So what's the size of the group we're picking from here? Looks like there's 18 people we have to choose from. Now, the number on the right is the size of the group you're picking. So what's the size of the group we're picking here? Looks like 3. So again, we start off the same way we did with permutations. There's 3 spots. How many choices for the first one? 18. Second one is 17, and the last one is 16. Remember, they're decreasing each time because Johnny can't be in the group twice, right? Once he's in the group, he's in the group. He doesn't get to go back into the pool. So 18 times 17 times 16, 4,896. Now, it's combination. So what do we need to divide by? We need to divide out the size of the group factorial. So the size of the group here is 3 factorial. Now what's 3 factorial? Remember, it's that countdown. 3 times 2 times 1. Count down to 1 and multiply the numbers together. 3 times 2 is 6. So 3 factorial is going to go ahead and get replaced with 6. Divide those on your handy dandy calculator. Boom, 816 different ways for that teacher to pick 3 students. So there's no excuse why we can't have different groups all the time, right? So plenty of different options. Let's do one more example just for good measure, right? Doesn't hurt to do plenty of examples. So Pizza Mind, your local pizza joint here, offers 10 different toppings for its pizza. 10. Suppose you order a pizza with 4 toppings. I love pizza. Okay, now I want to eat some pizza. Okay, so how many different combinations are possible? Let's talk about why this is a combination. Obviously it says combinations in there, but let's dive into it. So you're picking a group of 4 toppings, right? We're not going to have any repeats. We're not going to do like the double pepperoni or anything like that, even though that's delicious. Instead, we're going to go ahead and just pick non-repeating ones. And then reason why it's combinations versus permutations is that order doesn't matter. It doesn't really matter if you put mushrooms on first, then pepperoni. Some of you may argue with me, but in general, it doesn't really matter, okay? So let's go ahead and calculate this combination. So C4, combination. How many choices do I have? Well, it looks like there's 10 different choices for my toppings. And how many am I picking? Well, it looks like I'm only picking 4 of those toppings. So, apparently I don't know how to write an equal sign anymore. It's a good sign. Let's go ahead and calculate that. So 4 toppings we need to choose. How many choices do I have for my first one? It looks like I have 10. How many for my second, third, fourth? Because remember, we're not repeating here, so we have to decrease it by 1 each time. So 10 times 9 times 8 times 7. Looks like 5,040, but we're doing combinations here, so we need to go ahead and divide out all those repeats using the 4. So we're going to divide by the size of the group, which is 4 factorial, and we've calculated this before. Remember, it's just the countdown. So that was 24. And there is a button on your calculator for factorial. You just have to kind of search for it, but it is possible to do it on your calculator. Just an operation, just like division or anything like that. So we're going to divide that by 24. What does that get us? Looks like it gets us 210 different ways of ordering a pizza. So 240 different combinations. I'm going to bet you some of those combinations are pretty nasty. I'm not a black olives, can't stand that. So some of them you may not want to try, but that doesn't mean there aren't those combinations. So that was our final way of counting the possible outcomes. So make sure you review the differences between them below in the notes, and then let me know if you have any other questions.